welcome to our channel. After a long back, after. So we are discussing in a chapter of in class 9 physics first chapter motion. Okay, motion can be described in various definitions. Okay, but after observing all definitions, we can conclude in only one definition. So we can write in motion is the change in position of a body with time. So let us explain briefly. What is this change in position? Motion is the change in position of a body with time. So what is this? So we can understand this definition in an example. Now take an example. So I am at rest position. So I am not moving here. So now I am at rest. But I changed my position to here to there. Okay, I changed my position. Now what happens when I change position? So I have taken some time to change my position. Is it right? Yes. From there to here I changed my position. First of all, I am here rest, but I changed position to there. So I have taken some seconds time to change my position. Now let us see the definition. Motion is the change in position of a body with time. Let us see the example first. I changed my position with the help of time. Is it? Yes. So I changed my position now with the help of time. That changing of position with the help of time is called motion. Once again I repeat, the changing of position with the help of time, that is called motion. Simply we can say. Okay. Now, so motion can be described in many ways like distance, displacement, velocity, speed, like that. First of all, we will discuss about distance and displacement. Okay. So now we will discuss about distance and displacement. First of all, motion can be described in terms of distance or distance moved or displacement. Okay. First of all, what is distance? So distance we can say in different examples, right? Okay. So distance we can explain with different definitions or examples. So we can say simply that the space between two objects, that space movement to different objects, like that. Some definitions we can say, but the real definition of distance is distance moved is the actual length of the path travelled by a body. So distance moved is the actual length of the path travelled by a body. What is this actual length of the path? Let us take a single path. Let us take a uniform path, uniform direction, one single direction. In the same direction, in only one direction travelled by the body, distance moved in the actual length of the path. So take an example. So we are at the 0 meter. We travel to 30 meters. That is in the uniform path. That is called distance. Distance travelled in the actual length. Length is 0 to 30 meters. The length is actual, not excess 30, not below 30. 0 to exact 30 meters will travelled in a single path. That is called distance. Now write the definition. Distance moved in the actual length of the path travelled by the body. Okay, travelled by the this is called distance. Okay, now what is displacement? We discussed about motion and distance. Displacement, what is displacement? Let us see. So write down in a paper or any notebook or take a screenshot. Now displacement. So displacement is nothing but displacement we can now see with an example. Then it will clear. Okay. With one example, displacement will be clear over. So displacement is nothing but is the length of the shortest path. Length of the shortest path travelled by body from initial position to final position. So in velocity we are going to discuss initial velocity and final velocity, but here displacement initial position to final position means what is this initial position and final position? Let us take an example that a ball. So a ball is in hand and we are trying to spin the ball. First of all, while trying to spin the ball is in hand and that is releasing out. The time when the ball is in hand only, that is the starting position and that is the initial position. So what is now final position? When we spin the ball and it strikes the ground and it touches the ground, that position, that point is called final point or final position. Okay, the ball where started in the hand is called initial position and the ball where landed on the ground, the exact position that where the ball is landed on the ground, that is called final position, and the exact position the ball where is in the hand, that is the initial position. That is the difference between initial and final. Okay, displacement is nothing but displacement in the length of the shortest path. The ball shortest path only, no, the where travelled and where landed, travelled by the body from initial position to then striking the position which is final position. Okay, that is nothing but displacement. Now let us see the types of motion. So I think you understand the displacement. Displacement is the actual length of the shortest path travelled by a body with the positions, two positions, initial position and final position, like that. Now let us see the types of motion. It's very interesting and very easy to understand this lesson, and after we will go to some new numerical problems and again the types of motion. There are two types of motion actually, uniform motion and non-uniform motion, and there we have rectilinear, translatory, rotatory, oscillatory, rectilinear motion and so on. Next we discuss about some equations of motion is there and some numerical problems will be. Let us discuss now uniform motion. Uniform motion. So uniform motion is nothing but if a body travels the equal distances in equal intervals of time, that is uniform motion. Let us take an example. Let us take Olympics games only. In the Olympics games we have 100-meter race. The runners will participate, the athletes will participate, sorry. Okay. Now some athletes will run, so all the athletes will run 100 meters in 100 minutes, that is uniform motion. Means they travelled 100 meters, they are going to travel 100 meters in how many minutes? 100 minutes, right? Means both are equal, the time is equal and the distance travelled is equal. So the distance travelled, the equal distance travelled in the equal intervals of time is called uniform motion. Let us write the example. The distance travelled by the body the equal distance travelled by body, the equal distance travelled by body in the equal travelled by the body in equal intervals of time. In equal intervals of time. That is called uniform motion. Take an example. Again take another example. A body travelled in 10 meters in 10 minutes, 20 meters in 20 minutes, 30 meters in 30 minutes, like that. Equal distances in equal intervals of time, both are equal. And I think you must know about non-uniform motion also when seeing here in uniform. So non-uniform is nothing but same but some different. The unequal distances, not equal distances, here it will come unequal. The unequal distance travelled by the body in equal intervals of time means in 30 minutes when the body travels only 20 meters, that is called unequal distance. Okay, when a body travels 40 meters in 50 minutes, that is called non-uniform motion. If a body travels unequal distances in equal intervals of time, that is called non-uniform motion. So, I think you must understand very well today's topic is very interesting and going on so many parts. Okay, I think you must be understand very clearly this topic. Today we discussed about motion, what is motion and what is distance, displacement and types of motion. So, tomorrow we will discuss further more types of motions and more numerical problems and more equations of motion and so on. Okay friends, take care at the home, and if you like the video, press like button. Please don't forget to subscribe. If you are like to subscribe only, please subscribe. Okay, if you like the video, like button. If you don't like the video or don't understand the video, press unlike button. No, don't worry. And if you have any doubts, please put in the comment section. I will definitely answer. Okay, thanks for watching and see you in the next class. Bye friends.